In a clean room in Redondo Beach, California, banks of white light bathe a circular mirror 2.4 meters across, the exact width of the one at the heart of the Hubble Space Telescope. Technicians in white suits move around it slowly, the way people move around something they are afraid to damage. This mirror has spent most of its life in the dark, wrapped in plastic in a warehouse, sealed away from dust and moisture and stray fingerprints, unused. No starlight has ever touched its surface. It was never built to look outward at all. It was built to look down. It was made for a different agency, for a different purpose entirely, to watch the ground rather than the sky. And for years almost nobody outside a small circle of cleared engineers knew it existed. On August the 30th, this same mirror, repurposed and renamed, is scheduled to leave Earth on top of a rocket. Instead of watching a border, it is about to spend the next several years staring at the birth of galaxies. This is Objects in the Dark, a quiet place for the true stories of things out there. If this is your first time here, consider staying a while. There is no shouting in this channel and no scientists being stunned. Just real objects and the long histories written into them. Here is the promise. By the end of this film, you will know exactly what this mirror was built to do in its first life, and what changed its assignment completely. You will also learn that the government that eventually agreed to launch it tried to kill the mission twice, in writing, in official budget documents, years apart, and that the woman whose name is now painted on the side of that rocket died 3 years before anyone decided to put it there. Stay for how close this came to never happening at all, and for what this mirror is now going to spend the next decade looking at instead. The story starts with a girl who loved the sky before anyone told her it was not really meant for her. As a child in the 1930s, she set up a small astronomy club with her friends, meeting after school to map constellations from a backyard, using a notebook instead of a telescope because nobody she knew owned one. In high school, a guidance counselor tried to talk her out of taking a second year of mathematics, on the grounds that it was not something a young lady was likely to need. She took the class anyway. She went on to earn a doctorate in astronomy at a university, at a time when almost no women in the country held one, and afterward found that a doctorate alone was not enough to open every door in an academic world still built almost entirely around men. So she moved instead into research work at a naval laboratory, doing careful, unglamorous measurements in radio astronomy, the kind of quiet, exacting research that rarely made headlines but slowly built her a reputation for precision and for finishing what she started. In 1959, a brand new government agency, built to answer a single enormous question about whether human beings could survive and work in space at all, hired her to be its first chief of astronomy. She was one of only a handful of women in that building, and her job description was both enormous and vague at once. Decide what kind of astronomy this new agency should even attempt to fund, out of a universe of possible projects, and then convince the people holding the money that her choices were worth paying for, year after year, for as long as it took. What she pushed for, more than anything else, was a telescope in space. Not simply a bigger version of what already existed on mountaintops around the world, but something free of the one problem no ground-based telescope could ever fully escape: the atmosphere itself, a moving, blurring, light-scattering ocean of air sitting between every observatory on Earth and the universe it was trying to study. Put a mirror above that ocean, she argued, and the sky would finally hold still. Through the 1970s, that argument had to survive Congress, year after year, budget line after budget line, in a political climate that saw plenty of expensive space projects quietly die on paper before they ever left the drawing board. She was often the one in the room defending this one, in testimony, in hallway conversations, in the slow, unglamorous, grinding work of keeping a single-line item alive through one appropriation cycle after another. It worked. In 1990, the telescope she had spent the better part of 2 decades fighting for finally reached orbit. People would later call her the mother of that telescope, because in the long years before its name became famous, she was one of the very few people making sure it survived long enough to have a name at all. But even before that telescope launched, she was already describing its central limitation to anyone who would listen. It could see extraordinarily far and extraordinarily sharp, but only through what amounted to a narrow straw held up to one small patch of sky at a time. What she wanted to build next was not a sharper straw. She wanted a wide window instead, an instrument willing to trade some of that tight, careful zoom for an enormous field of view, wide enough to survey huge stretches of the universe inside a single frame, instead of one careful keyhole at a time, one target at a time, for as long as anyone could afford to keep pointing it. The telescope she had already fought for was no sure thing either, in those years. Its own construction ran years late and far over its original budget, and more than once, people inside the same halls she worked in argued it should simply be canceled and the money spent elsewhere. It survived those arguments the way most difficult things survive, not through one dramatic rescue, but through a long series of smaller ones, meeting after meeting, budget cycle after budget cycle, until it was finally too far along to kill. That idea sat mostly on paper for years afterward, waiting for a mirror large enough and expensive enough to be worth building around. Then, in 2012, in a story that had nothing to do with astronomy at first, the nation's spy satellite agency quietly admitted something unusual to the space program. During a Cold War-era reconnaissance effort, it had built more space-grade optics than it ever actually ended up needing. Sitting in storage, unused, uncontaminated by dust or sunlight, protected exactly the way a mirror meant for space has to be protected, were two mirror assemblies, identical in size to the one already orbiting inside that first telescope. Built to watch the ground in secret, for a government agency whose budget was itself classified, they had never once been launched. Rather than let them sit in a warehouse indefinitely, that agency handed both mirrors over to the civilian space program, at essentially no cost, with barely a public announcement at all. For the astronomers who heard the news, it must have felt almost unreal. The single most expensive part of any space telescope, the part that takes the longest to design, grind, and polish to a precision measured in fractions of the width of a human hair, had simply arrived, twice over, already finished, from an agency that could not even fully explain what it had originally been for. One of those two donated mirrors became the physical heart of the instrument this film is about. 4 years later, in 2016, the space agency formally committed to building a wide-field survey telescope around it. The wide window that had been argued for since before that first telescope even flew, finally handed a mirror large enough, at last, to be worth the decades of waiting. Large space missions do not get funded once and then simply left alone to be built in peace. Every single year, a new federal budget has to move through Congress, and every single year, that budget is effectively a fresh vote on whether a mission this expensive is still worth finishing. For most of this telescope's long construction, that yearly vote broke the mission's way. Twice, it very nearly did not. In one federal budget proposal, the mission's funding was set, in writing, at exactly zero. Canceled on paper in the middle of construction, mirror already sitting in the building, engineers already at work around it. Congress overruled the proposal and restored the money, and the work continued without most of the public ever noticing how close it had come to stopping. The very next year, in the following budget cycle, the same mission appeared on the same kind of list again. Funding proposed at zero. For the second time in 2 years, the identical fight fought all over again from the beginning. What zero means in a budget document is simple and brutal at once. It does not mean slower progress or a smaller version of the same telescope. It means the program office closes, the contracts stop, and the mirror that had already been waiting for decades goes back into storage, indefinitely, with no promise it would ever come back out. Each time the number appeared, astronomers, engineers, and scientific societies wrote letters, gave testimony, and made the same argument all over again to the same committees. And each time, that argument held. And in the middle of those two near endings, on Christmas Day of 2018, the woman who had spent 60 years arguing that telescopes exactly like this one were worth building, worth funding, worth protecting through budget cycle after budget cycle, died at the age of 93. She never lived to see her name attached to any of it. She never found out that the mission she had helped make possible would have to survive being canceled on paper, not once, but twice, in the very years surrounding her own death. 2 years later, in 2020, the space agency gave the mission a new name. Not a string of letters describing its technical function, the way most of these missions are named, but a person's name instead. The Nancy Grace Roman Space Telescope, the first flagship space telescope NASA had ever named after a woman. She was not there to hear it. The fight that had defined most of her working life, the one for a telescope worth keeping funded year after year against every argument that it cost too much, was being fought again, for an instrument now carrying her own name across its side, and she missed it by less than 2 years. What follows is construction, mostly invisible to the public and largely unglamorous by design. The mirror integrated carefully into its instrument bay. A folded golden sunshield, built to unfurl exactly once in space and never fold again, because there is no repair truck waiting nearby if it jams. Years of testing inside vacuum chambers built to simulate the cold, airless, unforgiving conditions the telescope would have to survive without a single human visit, ever, for the rest of its working life. Along the way, engineers tested the golden sunshield by unfolding it, slowly, inside a chamber built to mimic the vacuum and temperature of deep space, watching every hinge and cable through cameras, because a shield that fails to open correctly once it is actually in space cannot be sent back for adjustment. There is no second attempt built into a mission like this one. Every fold has to work, the first time, permanently, or the entire instrument behind it is exposed to sunlight it was never designed to survive. Today, that work is finished. The telescope sits fully assembled at Kennedy Space Center, ready, and on August the 30th, it is scheduled to lift off from the same stretch of Florida coastline that once sent astronauts toward the moon, riding a Falcon Heavy rocket up into the dark. It is not headed for a close orbit around Earth, the way that first telescope still circles the planet today. It is headed roughly 1,000,000 miles outward, to a quiet gravitational balance point on the night side of the planet, where the pull of the sun and the pull of the Earth cancel each other out just enough to let a spacecraft sit almost still. There, it will join the James Webb Space Telescope, holding station in the same neighborhood of space, both instruments watching outward with Earth and the sun always safely at their backs. Once it arrives, this telescope will do something almost no instrument before it has managed at the same time: hold that first telescope's exact sharpness, while looking out through a window at least 100 times wider. A single exposure, one frame, will cover a slice of sky roughly 100 times larger than anything Hubble could capture at that same clarity in one shot. Over its working life, astronomers expect it to record the light of roughly 1 billion galaxies, enough to map, in fine and rigorous detail, how the pull of dark energy has been quietly stretching the universe apart across billions of years of cosmic history. It will also do something the mirror's original designers never once imagined for it. Instead of tracking a single point of interest for a few minutes at a time, it will stare, unblinking for years, at dense fields containing hundreds of millions of stars at once, watching for one specific brief kind of flicker. The moment a star's light bends and briefly brightens over a matter of days, because an unseen planet, invisible on its own, has drifted directly between that star and this telescope's mirror, its gravity acting, for a little while, like a lens. Multiply that flicker by hundreds of millions of watched stars, patiently, over years, and astronomers expect this single instrument to catch the fingerprints of thousands of worlds that no one has ever seen directly, and never will. Not portraits, fingerprints. In this line of work, that is more than enough. Neither of those two projects, the map of dark energy or the census of hidden worlds, was ever possible with a narrow straw. Both of them needed exactly the thing this mirror was never originally built to provide. Not depth, but width. A wide, patient, unblinking eye, watching a huge stretch of sky all at once instead of one careful target at a time. The mirror that was built to watch one strip of ground, in secret, for an audience of a few cleared officials, is about to spend the next decade doing the exact opposite of everything it was originally designed for, watching everything for everyone, and reporting all of it back. Right now, while you are listening to this, that mirror is sitting inside a clean room a short drive from a launch pad, sealed against dust, waiting for a countdown it cannot hear and would not understand if it could. It does not know it is named after anyone. It does not know it was nearly canceled twice before it ever left the ground, in 2 separate years, by 2 separate votes that could easily have gone the other way. It is simply the largest, most patient piece of unfinished business one astronomer left behind when she died, still waiting, more than 60 years after she first argued that something like it should exist, to finally open its eye. Soon, if all of this goes the way it is supposed to, a rocket will carry it past the clouds, past the last curve of the atmosphere that gave her so much trouble in the first place, and out toward a point in space where it will sit for the rest of its working life, patiently gathering the light of galaxies that have been traveling toward Earth since long before any human being existed to name them, let alone argue about whether they were worth the cost of looking at. Most people will never know how many times a mission like this one gets killed on paper before it ever reaches a launch pad. You know now. And the next time NASA announces something this telescope has found, somewhere out among a billion galaxies, you will know exactly what had to survive first twice, in writing, for that discovery to exist at all. Which fight would you have kept funding? I read every one of these. I will see you in the next one.